Hello everyone. So in this video I'm going to explain about today lead for daily challenge. So today's question is construct binary tree from preorder and inorder traversal. So in this question they are given the two integer arrays which is preorder and inorder, where preorder is the preorder traversal of the binary tree and inorder is the inorder traversal of the same tree. We want to construct the binary tree and return that. Okay, so we want to construct a binary tree from preorder and inorder arrays. Okay, in this, so let's see the example. So in this example, they given us the pre-order and the inorder traversal array. We want, based on the details, we want to construct the original binary tree. Okay, the original binary tree must match with the pre-order and inorder traversal order. Okay, so this is the question. So in this question is a medium level question. Okay, to solve this question, we must want to good understanding about the pre-order and inorder traversals. What is the pattern in the present in the inorder and pre-order traversal? So if we only have this understanding, then only we can solve this problem. So let's move on to the solution part. Okay, before moving to solution, first we want to understand how the inorder and pre-order works. Okay, let's take the small tree. Okay, this has two children, root, and it has two children. Okay, so let's consider in inorder traversal. First, in inorder traversal, it is first go into left. Okay, it is start from left and it move on to root and it move on to right. So this is the inorder pattern. So the same now move on to pre-order pattern. Okay, the same tree. So first it will explore this left subtree. First it will explore the root. Okay, then it explores its left subtree. Then it will move on to right subtree. Okay, so it's a clear understanding. So it first explore root, then it will explore the left subtree and its right subtree again. So this is the you can see. So this is inorder. This is preorder. So in the clear differences you can see the difference is mainly is in inorder traversal it's explore first left subtree, then it's move on to root. In preorder traversal it explores the root, then move on to its left subtree. So it is the reverse of these operations. Okay, so you can now play. If you look at the right subtree is same. Okay, it's just after root, then only it will explore the right subtree. So the main change is the exploration of left subtree. So the main problem is present in this, how we want to find the left subtree. How we are going to find the left subtree? Okay, now let's move on. So consider the again. So another subtree. Consider another subtree. So okay. So it has many left subtrees, okay, and it has right subtree, many right subtrees. So now we are present in this. So we have two arrays, which is one is pre and another one is in. Okay, we already discussed pre is starting from root. Okay, now pre is present is here. So this is the root. And in will start from there. So so this is the first element. This is also consider this also. So root is pre start from root and in is start from its left subtree. So now we build our root. So now we want to build the left subtree. So to build the left subtree, how we can build? Okay, so we want to split this both inorder and preorder traversal. Okay, elements which is okay. We want to split this two arrays because in this you can see these problems come under divide and conquer concepts. Okay, after building this root, we want to build the left subtree and we want to build the right subtree. So now focus on left subtree. So to build the left subtree, we want to divide this array only which contains the left subtree parts. Okay, so now we want to find the left subtree elements. In preorder traversal, we already said in preorder traversal, after visiting the root, we want to find the left subtree size. Okay, the left subtree start from pre. So this is the our current element. So pre plus 1 to okay to left subtree size. Okay, left subtree size plus pre. Okay, pre plus left subtree. So this is the so pre plus 1 to left subtree size plus pre. So this is the contents of left subtree in preorder traversal. This is the preorder. Okay, this is in order. Okay, so this is the pre means preorder index, our root index in preorder array, and left subtree size is the size of the left subtree from the size of the left subtree. Okay, so it starts from pre plus 1 to size of the left subtree. So how you are going to find the size of the left subtree? So I will explain later. Okay, now hold on. So now we find out the limits of pre in left sub preorder traversal array in left subtree. Now I want to again find out the left subtree part in inorder traversal. Okay, you can see inorder traversal starts from this element. Okay, from left part. So our first element is this part. So our starting position is from n start. Okay, our starting position is in. So this is the in, like our current index. So this in index plus. So it is start from this and plus in plus size of the left subtree, because it start and explore its all left subtrees and again return to root. Okay, so it starts from the current index, current in index, and end in plus size of the left subtree. Okay, okay, size left. Okay, so this is the inorder arrays left subtree part. Okay, again you want to do the same operation for right subtree. Okay, so you can see the right subtree start from for preorder array. The right subtree start from root plus 1. Okay, which root means this is the start point of pre. So pre. Okay, in preorder traversal I already explained the preorder it will explore all the left subtree parts, then only it move on to right subtree. You can see in this diagram. So its starting point is so pre plus left subtree size. Okay, the size of the left subtree. Okay, plus 1, because this is the size of the left subtree. So root plus size of the left subtree plus 1. So this then only it will reach this point. I hope you understand. So it will look like a little complicated one. So try to do paper, write in paper. Then only you can understand. Okay. The same way for inorder traversal, for inorder array to right subtree is, so we can see the inorder traversal is starting from this, it visits left subtree, then it come to root, then it will visit right subtree. So the inorder start also in plus. Okay, this is the in index, then it plus the size of the left subtree. Okay, size of the left subtree plus 1. Okay, because in starts here, so size of the left subtree is this part, then plus 1 is reached the plus 1 is reached to this part. Okay, okay, size of the left subtree means they include this index only. So this plus, so if we include this element also left subtree, then it will reach this point. Okay, then we want to plus 1, so it will reach the right subtree, because in inorder traversal we visit the left subtree, then only we visit the right subtree when we visit the root and the right subtree. So I hope you understand. Maybe it look like a little complicated one, so try to do by yourself and try to draw like this. Okay, some example trees, small trees, then only you can understand. Okay, I'm not going to explain about deeply about any example, so just because you clearly understand this part, then you can easily solve this problem. So I will just give the introduction, give some overview about the example. So you can see, okay, in this part, this is the in preorder, our first element is the root. Okay, now I find the root. Now I want to find the where this element is present in the inorder traversal, because we want to find the root index in both inorder, preorder and inorder. So root is present in that. Okay, so which tell that so before from this element to this element, so which I will draw. You can see in the tree. The tree in start from visiting left, initially start from left. Okay, it visit all the elements in left. Okay, then it reach the root. In pre, it starts from root and visits its left subtree. Okay, hope you understand. So there is a main part. So I forgot to explain that how we can find the left subtree size. So this is the main part. Okay, in start from left, it start visiting left sub part, then it move to root. In pre, it start from root, then it move to left. Then it moved to left subtree. So if the main concept is, if we find the index of the root element in inorder array, then the difference between the index size index is the number of elements present in the left subtree. If you understand this point, you can clearly solve this problem easily. Okay, because this is the root element of this, then it will visit the Inorder Traversal visit all the its left subtree elements, then only it move to this root element. So if we find out this root element, this element in both array, in array index in both array, so if we found difference between this in two indexes, then that's the left subtree size. Hope you understand. So now let's move on to the example part. Okay, you can see, so the root is now is 3, so the root is present in the Inorder Traversal this position. So the difference between this position is 1. Okay, because 1 minus 0 is 1. Okay, so this 1 indicates the size of the, so this is the root, the size of the left subtree is 1. Okay, there is only one node. Okay, you are going to divide this array into two parts. How I explain, so how we are going to divide this, so I will explain this in previous algorithms part. So hope you understand. We're going to divide this based on the condition. Okay, the size of the left subtree is 1. So I'm going to divide the preorder into from preorder start plus 1. Okay, so from this part to size plus size. Okay, from pre start plus size. So this is also this. So I'm going to divide this. This is the left subtree. Again, so in start is for Inorder Traversal left subtree is from in to in plus size. So this is the in start, and end is the in plus size. So this is the left part of our tree. Okay, I'm going to recursively call this function, and it will explore again recursively. The right part is if you do in the if you use this formula, you can find this is the right part, and the right part is in Inorder Traversal. This is the right part. Okay, so we recursively call this function again, so then we can build the array. Okay, hope you understand. Try to do by yourself in paper, so then only you can understand. So now move on to the coding part. Okay, the coding part is look like it's big, but it's big only because I write in clear ways, so that's only look like big. So first, initially I found out the index positions in Inorder Traversal. So I will store the Inorder elements position in array. Okay, because you can see in algorithm part I find out the if this is the root, so I want to find out the index in Inorder Traversal array. So to reduce the time complexity, so I use the map to store the position of the Inorder array element in the array. Then I will create create a tree function. So which preorder, and this is the preorder start, and this is the preorder end, and it's the inorder, so it's the inorder start and it's the inorder end. So it's so in this function, if the pre-start is greater than pre-end, okay, which means our pre-start is exceed the pre-end, then we abort the process again. And also if the in-start also greater than the in-index, it means our starting in-array index is exceed the in-order array index, then again also we will stop the process, return the null. If otherwise, I will find out the root element. So the root element is I already explained the starting element of the preorder array. Okay, so again I will create the new root element. Then I will find out the root position in the inorder map. Okay, this is the position of the root element in inorder map. So now I want to find the left subtree size. So again I will already explain. So I already explained. The left subtree size is the inorder root element in inorder array minus inorder start. Okay, so this will give the root size of the left subtree. Okay, so I will explain again. So maybe you confused. So this is the inorder. So if you find out the inorder size, okay, inorder root element in inorder array. So from in start to the difference between the in start to in root index, so that is the size of it. size of the left subtree. Okay, this is the in start. So this is the root value. So difference, so it will explore all left subtrees, then only reach this point. So difference between this two index is the size of the left subtree. So that's the, so that is calculated in this part. Then I will find out the left pre-start. This four values I already explained in the algorithm section. So left pre-start is pre-start plus 1. So you, if you remember the tree, you can easily write this 8 points. So go through this 8 point by yourself. Okay, I already explained this algorithm, but kindly, if you did not understand, kindly rewatch that part. Okay, again I will call the root left part. So I will, it's a divide and conquer part. So I will divide this array into two parts. So I will first call the left part, pre comma left to pre start and left to pre end, and in in array the left in start to left in end, and the same way in right, from right pre start to right pre end, and also in from right in start to right in end. So it's for right part. So then after building this array, build this tree, I will return the root. Okay. So finally the tree, builder tree will be returned to the main function. So this is the solution for this problem. So now let's submit this. So accepted. So the time complexity is just order of n is the number of element in the tree. So the space complexity is, there is also order of n, because it is we use the in-order map. So in-order map to store the index values. So hope you all understand. If you have any doubt, please kindly ask in the comment section. So thank you all. Let me meet on next LeetCode daily. Bye.